Alright. Okay. All right. So I hope everybody had a good weekend. Sorry we're here on such a gorgeous day, but if you didn't get out this weekend, you should have. It was nice. All right. So today we're going to go over virtualization and chapter 7. But first to go over, so you still have the video project, right? Still remember that is outstanding, and the outline and the intro paragraph is due by Sunday.
I just have some questions.
Yeah, go ahead.
You said on all those, we can just submit the entire thing for each one of those?
You can.
And it's for the actual page, is it like double space? Or?
Yeah, double space,
Okay.
12 font is fine, you know. But yeah, you can use MLA or APA. I'm not an English teacher, so I'm looking just for content, not, you know, I won't even take spelling errors off because I'm a terrible speller. And so, you know, I'm looking for content. What did you get out of the video? But yeah, double spaced, 12 font, and you shouldn't need any outside sources. It should just be the video. So you don't have to list the video, but you can if you want to. But please don't use any outside resources. But if you do, you know, list them. But 5-hour video, you should have plenty of material.
The question is like, why is it low quality?
What?
Why is the video so low quality? It came out like 2 years ago.
It's from Google, so I don't know.
No, it's like.
Yeah, yeah. Don't ask me on that one. I don't know, but the content's good. So, but yes, you would expect probably a little better quality. Yeah.
We're using over Google.
This week we got the wireless radius packet tracer lab that's due. I kind of went over that last week on how to do that. Many of you have already submitted it, so and got it. But that's what you'll be working on in the labs this week. So one of the things, though, I do want us to do before I start lecture is what we're going to do is we're going to create a virtual machine. So what I need you to do is go to your K drives. And I'll get you the file. I brought a USB stick, so because you're not a Northeast student yet, you won't have access to our K drive. It's a special drive that only Northeast students have. And but go to the K drive, JSpicer, and the ITNW 1425 folder. All right, and within there is the Windows folder, and highlight, right click the EN Windows 10 ISO and copy it. All right, so hopefully we have a D drive, and just create a new folder there called ITNW 1425, and then paste that file in that location. I'm going to put it on my USB drive because I need to use it. So it's the EN. So here, let me get. Yeah, it's in Windows. So classroom files, JSpicer, ITNW 1425, Windows. That's the EN Windows 10 Business Edition. It's that really long name. Anybody else still having trouble finding that?
Oh, no, I'm
Oh, yeah. What's that?
I was just gonna say, remember, on busy house where I crashed the computer, I have virtual machines?
Don't crash this one here.
I'll try now.
Okay, yes. Right, so K drive, right? And then JSpicer.
I got been the duck. Appreciate it.
Oh, yeah, sure.
Yeah.
C drive. Right.
Yeah, we just created a folder and just put it in.
Oh. ITNW.
No, up to the very first 45.
Oh, so you started?
Yeah, I started, but I've been meaning to do stuff, other stuff. I got one that says, hey, come over, we paint today.
Okay.
Really?
Alright, anybody not downloading the file? Put it on the D drive, create a folder called ITNW 1425 and put it there.
I've literally set up. Yeah, just fix it all.
Yeah. I don't think, you don't have a cable.
I just watch an hour or watch a segment. And then watch a segment.
They hide that information from me.
I mean, the very first 45 minutes or so, it's just pretty much almost everything in mind.
All right,
Yeah.
everybody downloading this that wants to follow along? Okay.
Who wants to?
Well, there's some people that choose not
Wants
to.
to.
I have
Is this,
to,
are we
have
doing
to,
VMware?
you know, recognize that doesn't happen. Yes, sir. Yeah, right click copy. No, right click. Copy. And go to D drive. Oh, you don't have a D drive. No. Go to the C drive. Right click here, do new folder. And do ITNW. 1425. And hit enter. Another click in there. Right click and paste. Okay. All right, so this, as you can see, is going to take a long time, which is why I had you start now. But of course, we're, 15, 20 people downloading, 6 gigs of data on the network at the same time, so. Yeah, it'll slow it down, so yeah. Every other class is hating life because things are going slow. Oh, darn, yeah.
VM, I gotta download.
Right. Well, the good news is once we get it downloaded, then we can create as many virtual machines as we want. But all right, so I'm gonna let that go for a little bit, and then I'm gonna get. Let me see here. I need to get my presentation here. Lessons. Week 6. Okay. Slideshow. All right. So as I said, this is on virtualization and cloud computing. All right. What's up?
I was looking at the actual software, we put the VM software on here.
Okay. All right. So we're going to discuss virtualization. Anybody kind of give me an idea of what virtualization means to them? Yeah,
It makes a logical home of the computer inside of the physical host.
Okay, I'll go with that. Yes, definitely. Yeah.
Basically what he's building about, like something that if you have any, like a new update, you want to try it, you throw it on a VM, or any major changes, you throw it on there first, make sure it doesn't.
Right.
Very good.
Right.
I
We
mean,
definitely use it for testing software and solutions
Or just risky software or
right,
something.
risky software. But also we can create and manage entire networks virtually now, and actually run production level networks within a machine. Right. It's really crazy where we're going. So virtualization, right, creates that logical view, or virtual. I hate when they use the definition of a term in the definition, right? You know, it's a virtual or logical version of something, right, rather than the physical version. And then the host, right? So we'll be creating some virtual machines, and our host will be our desktop, our student machines in here. The actual physical machine will be the host of our virtual machines, which will be guests. So that, you know, that's a term that we use for a virtual machine or device. It's a guest on the host. And then we run these in what's called a hypervisor. It's basically the software that manages our virtual environment and it manages our virtual machines, resources. One of the hypervisors is VMware, which is what we'll use here in class. But there's VirtualBox, there's Hyper-V, there's a ton of others, but those are the three main ones that you'll hear. But in production environments, it's going to be VMware or Hyper-V typically. Hyper-V being Microsoft's version.
Boxes for,
What's that?
or boxes for the Fedora.
Fedora, yeah. But yes, but they're all different versions of hypervisors. And this is just a depiction of our machine. I mean, it looks just like our machine. And it's got a physical network card or NIC. It's got a couple of virtual machines that are encased within a hypervisor, right? But it runs on the physical computer. Now we have two types of hypervisors. We'll use type 2 in the class because we have to have our OS installed first, and that's Windows. You know, in this case, we're running Windows, and we install VMware's hypervisor, VMware Workstation, onto our machines. So it's a type 2 hypervisor. But we do have a type 1 hypervisor that you can install what they call bare metal, and you don't need an operating system. It is the operating system. And you know, that'll be like VMware's vSphere, but Hyper-V also has a version that's both type 1, type 2. Type 2 Hyper-V comes with Windows Pro. So if you have Windows Pro, you already have a hypervisor installed. It's not enabled, but it's installed. All right, so we can do all kinds of things with the VM, with its software and hardware. One of the beauty things of a virtual machine is we can add RAM or CPUs or hard disk space very easily compared to a physical box, which may actually take more time. But let's see here what we got there. You'll see this screen. This is from VMware, and this is a view that we'll have here just shortly, how to manage that virtual machine and manage its hardware. And we can change, in this case, how much memory that virtual machine has just with a slide dial, right? Now you have to have the actual memory on the physical box. Memory is one of the few items that you can't over allocate. So if you want to give a virtual machine 32 gigs of memory, well, your physical machine better have 36 gigs of memory because you need some for your machine, right? So you can't over allocate memory. But processors, you can actually over allocate, and this is where virtualization really shines, because processors work, so fast. A lot of these, 3, almost 4 billion instructions a second, right? We can over allocate processors, and as far as we are concerned, it's simultaneous. So we can over allocate. Say you have 4 cores on your box, you could easily assign 12 cores to VMs, and you wouldn't have any problems. So that is really one benefit of virtualization. And then hard drives, you can over allocate or provision, but you actually have to have the drive space when you go to use it, right? So most of the time you can say, say like when we do our install here shortly, we'll give it 60 gigs, and you can give all kinds of machines 60 gigs. But we have a limit of however many gigs we have on there, so that once you actually use the drive space, you better have the drive space. But network adapters, we can add all kinds of network adapters. There's only a limit to the hypervisor. The hypervisor limits how many network adapters you could have. But it's really easy to add network adapters and networks in virtual environments. So every VM has a virtual network card, right? It can have more than one. All right, so the hypervisor creates a connection between the VM and the host, and the connection is said to be bridged or switched. All right, you'll hear a lot of this talk about virtual switches, and we'll go here. So here's a picture here that shows our box, the host machine, and it's got 4 VMs. And it has what's called a virtual switch on the hypervisor. And then this virtual switch has a connection to the physical network card 1. So all these machines now have access to the network off of network card 1. But this virtual switch, it can have more than one switch in that Hyper-V. But what you're actually doing, you just think of it as plugging it into a physical switch, right? There's a physical switch that exists, but you can have multiple switches. And in this example, they broke out VMs 1 and 2 and 3 and 4 on different switches. In this instance, they are accessing different cards, physical card A and physical card B. But it's just as easy. They could have all still been going to physical card 1. So just because you have one physical card doesn't mean you can't have multiple virtual switches, because you can. It all depends on what you're doing. Now, in our network card configuration, I wonder where are we on this? Okay, so, all right, I'm going to at least, hold on one second here while I get this file checked. All right, here, Anna. Eventually follow along with this. All right, sorry about that. Okay, so we have 3 options that are most common in a hypervisor. We have bridge, NAT or network address translation, and host only. Let's see here. So in bridged mode, it's basically taking over the host machine's network card. It bridges right onto it. It goes right onto the network. And you'll see that what we'll do is we'll test all 3 of these when we get our VM running. But it puts the VM on the same physical network that the physical host is on. So if you got DHCP or whatever, it'll get an IP address and it'll appear on the network just like any other computer, because it's basically been plugged into that network. It will get its own IP address though, its own default gateway and net mask, etc. But it appears just like any other box. There would be no way to tell the difference between your classroom box and this box on the network other than its name. And so this is what it looks like in VMware. You can't really see it, but right now it's bridged is selected. I love it because the network adapter is still set to network address translation, so they haven't applied it yet. But network address translation mode, or NAT, relies on the host machine to act as a NAT or network address translation device. So what that means is it obtains IP addressing information from the hypervisor. It says the host, but the hypervisor acts as a DHCP server, and it creates a private network in your virtual environment. So your VMs now have private IP addresses, and they're not technically seen on the physical network. They can access the physical network due to what's called network address translation, but they're not connected directly onto the physical network. And this is a solution that if somebody needs to access your VM from outside your box, this is not a good setting to have, because it's not easy to get in to the box. Whereas bridge mode, it gets an IP address on the physical network. You can give that IP address out or its name, and the people can access the box directly. So even though it's on your computer, you could create a web server on your computer and put it in bridge mode and give somebody the IP address, and they can get to your website. You know, whereas if you do NAT mode, they're on a private network and it's not easily accessible from the outside. But anything on the box is accessible to potentially. And this is in network address translation mode, right? The DHCP service lives on the hypervisor, and it's giving out private addresses. As we can see, these have 10 network IPs, whereas the physical address has a 192. So they're on different networks, right? And so this device acts like a router if you want to get out to the internet and that, which you can, but it uses this IP address to get out. So these machines don't have their own IP address on the physical network. And then they show selecting NAT in VirtualBox, which is another hypervisor, one we won't use here. And then finally, we have host-only mode, right? So VMs on one host can exchange data between each other and the host, but they can't go out. You can't even get internet, you know. So you're locked to the box. Whatever box you're installed on is the only box and that you can talk to. So in this situation, right, VM 1 and 2 can communicate, but they can't get out the physical network card. They're locked in here. All right, so some of the advantages, right? So efficient use of resources, cost, energy savings, fault and threat isolation, simple backup and recover, replication, especially with some of the advanced versions. Hypervisors type 1s, you can drag and drop machines between servers and locations. You know, so you could technically drag a server from the East Coast to the West Coast and technically do that. And it'll just depend on your amount of data transfer. But disadvantages is, right, you could have compromised performance, definitely can increase the complexity. And technically licensing costs, I don't know how it really increases. You have to license everything in your VM world. that has a license. So, but the caveat is it gets super easy to add things and forget that you need to pay for a license, right? Because you'll see how easy some of this is. But then the single point of failure. So if you have, 100 virtual machines or servers running on a physical box, and that box, has a hardware failure, you just lost all those resources, just one failure, right? So, yeah, yeah. Right. So, I mean, it depends. I mean, if you're looking like, so a good example is you could have, a box that has 100 web servers on it. As long as you have multiple boxes, you're probably okay, right? Because no data really lives on the web server. The data lives on the database. And in a lot of cases, you don't virtualize your database servers, and on anything with that kind of level. If you had 100 web servers, your database is going to be physical or a bunch of physical boxes, most likely. Or if it is virtualized, it's a single box virtualized. Right, right. But hopefully, right, you've got backups and replications and all kinds of reasons that you can lose a box, right? Hopefully, you should be able to box in your scenario, but you lose a lot, by a single failure, right? Single motherboard, goes down, boom, right? Can cause issues. All right, let's see here. How are you on the file?
I need help with
Oh, okay.
where to go for the.
Oh, sure. Oh, you do have the KVAC. Oh, okay. Why don't we just do that? Okay.
Well,
Yeah. Maybe faster. Type ITNW. That's fine. Okay. All right. So what we'll do, if I go too far, let's go ahead and open up VMware. So what I'm going to do is go to our Start button and then scroll down, and there's VMware Workstation. All right, so everybody open up VMware Workstation. Under the Start button. All right. You should get to this screen here. Yes, sir.
I have two.
You have two.
I think so.
Just click here and just click left to it. And then don't have it. Huh. What? All right, try searching for it like you did. Yeah, try that. Yeah.
It's just not on that menu. It's over to.
It's weird that it's on the menu. Oh, okay,
There.
it opened. All right, it's very odd. Everybody got VMware open? All right. All right, so what we're going to do is we're going to create a new virtual machine. Click that right there. Now you can do a custom install. We're just going to do a typical install, so we're just going to hit next. And then we've got a disk image, installer disk image, and we're going to go browse that for that file we just downloaded, right? So it should be on your D drive, and mine is not on there, so I'm going to the K drive. Mine will take longer, but that's okay. So you find the file, click on the file. So you should have the Windows 10 Business going there, and then say next. Everybody here got the license. Did you already did the file already? Okay, good. All right, so normally we would put in our licensing code, but we don't need it for what we're doing, so we're just going to say next. And just say yes. Actually, you could say don't show again and say yes. So we'll just call this machine A1. And for the location, you're going to want to change that to the D drive. So go browse, select the D drive, and then select our ITNW folder, and then let's make a new folder called A1. So what we're doing is we're creating a folder for our machine, and then the machine's going to live there. So D drive, go browse for location, go to the D drive, find our ITNW folder, then do a make a new folder, A1, say OK, and name the machine A1. Everybody got this? Yeah. Right. So just hit next. Yeah. And then name it A1, and then go browse, D drive, and then ITNW folder, and then make a new folder. Okay. Yeah, and A1. Yeah. All right. Yes. Yes, sir. Oh, yeah, you don't have a D drive, so use your in ITNW folder. Just highlight that, and then you make a new folder, and then A1. All right. Okay. So now we've got our machine name is A1, and our folder location hopefully is the D drive. Unless you don't have a D drive, then go ahead and put it on the C drive. And then we'll go next. We'll go ahead and accept the default of 60 gigs and split virtually into multiple files is fine. We'll go next. And then we'll just go ahead and go finish. Now it's going to create our virtual disk and virtual machine, all the virtual hardware, and then it'll start up and hopefully install Windows 10 for us. But we probably have to do one thing, though, to get it to work, which is always fun. So when this starts up, what you'll need to do is click into the center of the black screen, and then when it says press any key to get to the CD, you'll hit the space bar or any key, right, so that the CD starts. But it's pretty quick when you need to do this, so it's okay if you miss it.
We did the NAT settings.
Right, it's on NAT right now, yeah. So it should start, there it goes, and you click into the center here, and then hit any key, and it should boot off the DVD.
Hey, Doc.
Yes.
No problem.
Yeah. 1 second. Oh, okay. Yeah.
Yeah, I'm good enough there.
Yeah, I it's the same thing.
Really?
Yeah.
Wow. Well, that's okay.
Who's in charge of the group policy?
Yeah, I don't know, but this is.
We need to-
I had about a third of the morning class have this too. Yeah. For whatever reason, your VMware was not running. All right. Oh, gee. Wow. What's going on? You have that too? Wow, this is like more than a third of the class. Who else?
Marcus.
Yep, yep. It's like almost the whole class. Huh? Oh, task manager. Oh, okay.
I wasn't paying attention.
Yeah, thank you. Yes, sir. Oh, you got it too. Okay. Yeah, it unfortunately it takes forever. It's a large file. Yeah, well, actually, if you want to go ahead and inject that and give that to him. Okay.
So yours froze up?
Yeah.
What did you do? Like, did it freeze up like that?
Yeah, it's just not letting me do anything at all. I just literally just closed it.
Oh.
Yeah, just closed all. So I was about to go fast.
You were the first one.
Fast time, just kill it, the old fashioned way.
All right.
Whatever. Got it. Need help
It may take a while for it to Oh. This time? Yes.
It'll take a second, but.
Yeah.
Appreciate it. I've done it. I'm not making one.
It's just gonna be setting up.
I'm setting up.
Yeah. Do it.
He cheated over
Right.
Figured out when to do what, as well as,
there. These are relatively fast.
Okay.
I'm thinking about setting up another VM, or setting up a VM on a main computer.
Oh, just before you put stuff on the computer.
Well, it's.
I already have some other that I already know and trust.
Give it a minute, hopefully it'll switch. All right, so we're installing Windows. Where's mine here? Looks like it's restarting. All right. All right, so hopefully once we get this going, we'll be able to show you some differences on the network card settings. But the good news is what we'll do is we'll be using this machine and we'll create another one or more because we'll do some other labs with these virtual machines just to give you some more experience with networks besides Packet Tracer. Now the good news is right in the announcements section, there's a link on how you can download VMware for free. So you can run it at home and also get experience that way at home. And you can download Microsoft, and And yeah, off Azure, right? And you can also get Ubuntu, Linux, and all kinds of other Linux devices that you can put on here. Let's see.
Is this 10 Pro?
10 Pro. Yeah, this is actually business. So take, not business, it's Education Pro, 10 Education Pro. It's actually all of them, but you can do the Education Pro if it asks you. Yeah, it's weird that not every installation happens the same way. It's the same file, but it is very odd that you don't get, this is computers. I don't know if we've told you this before, but this is one of the only fields I know you can do things over and over and expect different results and not be deemed crazy. Because it will happen. Yeah. We all did the same thing, but I'll guarantee you, everybody will have slightly different installation versions.
Yeah, it might just be Microsoft.
But it's not just Microsoft. It'll happen with other software as well. But yes, it is interesting. Because I've done it in my checkpoint firewall class. I will it invariably will get 20 students, and I'll have at least 5 different scenarios for when we're installing firewalls and doing things. And but there was one though, there was a bad version, and it was like every time the students came back, they got different results. It's like one week yours would work, hers wouldn't. The next week hers worked, yours wouldn't, and nobody changed anything. It was awesome. I about pulled my hair out for that semester. It was the first one I taught for. Yeah. Yeah. That class was fun, among other things, finding out that the classroom was underpowered and we couldn't run the full lab in there. Yeah. All right. So this obviously takes a while because we're installing Windows, but it's not too bad.
It's actually done. It's really fast.
Right, it's not too bad. Well, these are decent machines. And what do we got here? No, they're not too decent. I can't get Task Manager up. There we go. Not doing anything yet.
Yeah, it's nice stuff.
All right, so we got 4 cores, 8 logical processors. So it's got hyper-threading. So we've got 8, and then we've got 8 gigs on this machine. So I've got 8 gigs. So yeah, these machines are hurting. Yeah, I think we've got was it 16 cores and 32 gigs of memory in my firewalls class, but I had to upgrade it. But we're running so many VMs. We're running 3 firewalls, 1 management server, which the management server is 8 gigs of RAM, and 4 processors, and then like 5 or 6 PCs all at one time. So it has to have it. It wouldn't run here.
Yeah, it's super administrative passive, just a little bit of task management.
Yeah. Yeah, well, that's the one thing is once you get a VM, you'll be admin. So that's, you can do anything you want in a VM. That's one, yes. That is one thing, yeah. That every one of my classes, we install a machine just for that reason. Yeah, because well, just like just starting up VMware on some of these, I mean, I had to log in, give you admin rights to start up VMware, which was wrong. These labs should automatically start up. All right, so if you get the question, yes, that's fine. We can have it discoverable. All right, who's still installing?
Also creating the disk.
All right, still creating the disk.
Yes.
What happened?
Yeah.
Oh.
Yeah, should we start or something?
Okay. All right. All right, we'll give it a little bit. So what I'll do though is on mine right now, I'm going to go to a command prompt for CMD, and I'm going to just type ipconfig/all, which I don't know if I spell it correctly. ipconfig doesn't work. I don't know. So ipconfig/all, and then I get my IP address. All right, so let me get here. Yes, yes, sir. Oh, you need admin? $100.
$100.
Man, all right. I wasn't thinking, man, I could have been rich tonight.
I told you, see?
All right. It'll take a few minutes to start up. Yeah, go ahead. That's fine. All right, so my virtual machine IP is 192.168.197. Where is it? 128. Got 128. All right. Now I'll go on my physical box and run this command. CMD. And I run ipconfig/all. Of course, I have a few more because I have some virtual drive networks, but my physical 10.164, yeah, 164, I'm sorry, 82.159. All right, my desktop. All right, my physical computer, the desktop, has an IP address of 10.164.82.159. But the new virtual machine that I created has an IP address of 192.168.197.128. And as one of you pointed out, we set up, when we first installed this, the default is NAT, Network Address Translation. So what's happening is VMware is translating this 192 address to this 10 dot address when I go out. So when I go out on the internet, so I can reach the internet from my VM. I can go to the internet from my VM, but it's using my physical network card address. And then the funny thing is so mine is a 10 dot address, but I wonder what my real world address is. So what's my IP?
Mine doesn't have a 10.
Yours doesn't have a 10?
Mm-mm. It's close. 192.168.197.1.
Okay. That's your physical?
Mm-hmm.
Huh. Oh, scroll down. Or scroll up, scroll up.
Oh.
Yeah, scroll up. There you go. That's your physical.
Oh.
Yeah, your physical box will have multiple addresses because VMware has to create a virtual adapter. So the ipconfig/all will show some VMware adapters. So you got to scroll up on the physical one. So now my real world IP is 204.98.170.118, which if you go to what's my IP, right, you probably will get the same address because we all share it because they're doing network address translation for everybody in this building, right? So if I go to my physical box, I'll bring up Firefox here. Maybe. All right. Type what's my IP? Maybe. Oh, come on. Wow, these machines need more memory. I'm just running one machine. What's my IP? Oh, come on. Really? No. I don't care about that. What's my IP? I really want to do that. Wow. All right. So you see, it's coming up with the same IP address, 204.98.170.118. So my physical device and my virtual device have the same real-world IP, and I'm guessing all of you have the same real-world IP address.
Yes.
Because the campus is doing network address translation. So, but for our VMs, VMware, our hypervisor is doing network address translation between our VM and our desktop, and then between our desktop and the real world, the campus is doing network address translation yet again. So to the outside world, all of us are coming from this IP address, but it keeps track of each connection and goes back to the right machines. Yeah. But that's network address translation. So now, if I right-click on my tab on the A1 and go to Settings, and I choose my network adapter, and I go to Bridged mode,
What did you click on?
I right-clicked on the tab up here at the top that says A1 and go to Settings. And then go to Network Adapter. And then I switch to Bridged mode. And then I'm going to say no for discoverability on our student network. But now, if I do an IP config all, now my VM has a 10 network ID. It's now 10.164.82.174. So I went from that network address translation to bridged. And so it bridged me and put me on the campus network. So I got a campus IP. So it no longer has to do network address translation between the VM and my desktop. It'll still do network translation to go out to the real world because that's a campus setting. But I'm now on the same network as my desktop. Now, if I go in and right-click again and go to Settings and go to our network adapter, and we go to Host Only, and give that a second, and then we do IP config all. Well, I didn't give it enough time. Okay, so now, still not enough time. Okay, so now I'm on the 192.168 253.128. All right. So now I'm on a completely different network. So when I was on network address translation, I was on the 192.168.197 network. Now on the host only, I'm on the 192.168.253 network. We'll get into how I know where the network address is. But now I'm on a completely different network because now I can't get out to the internet. So now if I go, I only choose Bing because it's shorter. But as you see, it's just spinning and spinning because I have no internet connection because I am on a host only, right? I am no longer doing network address translation and I cannot get past my box. So this is great for if you're troubleshooting viruses or other things, right? You know, now I have a box that I can deal with, and I can even create other boxes inside my virtual environment and connect them together, and they can see each other, you know, and I can even put a web server and test websites and everything inside my box, but I can't go outside the box. All right. So then there's just one other thing on the settings. So what I can do also is I can create networks on VMware. I won't show you that because it requires admin access and you don't have admin access. Well, I'll show you. So if you, I'll cancel this. But so if I go to edit virtual network editor, which you won't have access to, I can click the change settings, and now I can add a network, right? And I got all these networks that I can do, and so I got VMnet2. I can make it a host only, I can make it a NAT, or I can make it a bridge network, and I can give it IP address ranges. I can set up a DHCP server, so I can create my own virtual networks. Because you don't have admin access and can't use that feature, what we can do instead is a little simplified, and we go to settings in our network adapter, and we've got these LAN segments. And if we click on LAN segments, we can just add, and we can just call this MGMT, right, for management. We can do, let's see here, public, and we can do private, right? So we can create all these segments so that then we got drop downs. And then any VMs that have the same label here can see each other. That's like creating a switch, you know. So what you're doing is you're creating a virtual switch in these LAN segments, and basically for any machine. So if I put management here, then it's plugging it into the management switch, and any other VMs that are plugged into the management switch will see each other, or can see each other. You now then have to give them the right IPs, and it's a little more work, but you can create these little networks that make it easy to manage. But we'll definitely get into that because we'll do that, and we'll leave these to where they're not connected outside, and we'll do some things. But for now, I just wanted you to see the differences between all the settings. So definitely feel free to play around with the settings on the networks and see what's what, but we'll definitely come back and utilize this more. I wanted to do that before we went too far. All right, let's see here, 6. All right, so besides our VMs, right, we can do network devices, right? So we can do virtual firewalls, virtual routers. In fact, if you take the firewalls class here at Northeast, you'll learn all about that because we use that. And you build all kinds of firewalls and routers. But so virtualized network functions, right? It can be done quickly. It's automatically migrated to one server to another in case of a hardware failure. You can utilize your resources more efficiently. And services can be easily scaled to meet the changing needs of a network, right? Because if you use virtual features, it's easy to scale. But if you use a hardware appliance, it's not easy to scale a hardware appliance. You got to buy more than you need, right? So we can do functions, right? Merging physical and virtual network architectures to provide flexible cost savings and many devices such as servers, data storage, load balancing, and firewalls. I mean, all these and more. I mean, just pretty much anything you can think of, you can probably virtualize now, and save time and money by doing it. But you will need licenses, and there will be a small degree of latency, so delay, right? Because it's got to go through that hypervisor, right? So it's not the same as physical, but usually it's close enough. But then there's a caveat. You know, some administrators are not comfortable using a virtual firewall to protect an entire network. Of course, if your whole entire network is virtualized, you know, probably could say that that's not a valid point, or at least majority of your network, I mean, can be virtualized. Obviously, you know, you have to have some physical network for something, at least a smartphone or tablets or some interactions, or most of the time it's not very useful. Now, software-defined networking, or SDN, takes this to a whole nother level. So you're not just virtualizing devices, but you're virtualizing and separating out the control plane, right? So you have it basically allows you to take control of the control plane and have a single pane of glass, as it's called, or just a single window to administer everything on your network. And then your physical devices, or VMs, have the data plane, right? And it's just like this. So traditional, you have control plane and data plane on your switch, a control plane and data plane on your router, you know, and then a virtual switch has a control plane, data plane. But in an SDN world, you remove the control plane and you put it into a control application, and then you just have the data planes on your devices, and you can manage everything from one application. Whereas before, you had to remote in to the switch, or remote in to the router, or remote into this virtual switch to administer it. Whereas here, you could administer everything from the control app, the control plane. And this is just showing another graph where you have, you know, the application layer, and they use APIs, application programming interfaces, to connect with the control plane, and then the control plane connects with the data planes and manages your devices. And then, so the primary advantage is you have centralized control of your network. I mean, it's just unprecedented, you know, the ease of which you can control your network, and the ability to implement even more sophisticated network functions with generic equipment too, right? So some of this functionality you can create with this control plane with low-level, entry-level devices, where before maybe you had to buy a real high-end device to get some functionality. you get it, because of the control plane being centralized. And then you can manage, and then some of these now can even manage resources that you don't even host. They're on other networks, right? So your organization doesn't even own the network, but you own the device or have access to the device, and you can now manage your devices in other networks, right? Think of cloud providers or things like that, right? So you can literally have one single application to administer and manage every network device in your company. I mean, that's just amazing to think of that. All right, so now we're leaving virtualization and we're going into cloud computing. All right, so cloud computing is on-demand service, supports multiple platforms, right? Metered service. Metered service is the key, right? So years and years ago, most computing was done off of a mainframe, and you basically rented time off the mainframe, and they charged you for every instruction that went through the CPU, right? So, and it was 1,000,000 instructions per second is what you were billed at. And so depending on how many instructions you used, that was your bill for the month. Then we went to the client server model, which has prevailed for a long time, and everybody owned their own equipment, and they didn't buy or rent. They bought the servers and hardwares and set up their networks, and they didn't rent anything, right? And now we're going back to the mainframe analogy where we're renting time for, somebody owns the equipment and we're renting time off the cloud or renting the applications, how many users use it, or, so it's a metered service. But we're doing it because storage capacity and availability can quickly and automatically be scaled up, right? Because they've already paid the money to have the ability to scale up. They have excess hardware sitting there waiting for you. So this is a great thing for like retail sales at Christmas time, right? If they had to have a physical network year round, I mean, 90% of the time, 90% of their network would be not utilized, right? They'd have to have thousands of machines for some of these stores, sitting idle for 9-10 months of the year. Whereas with the cloud scenario, they can just go out and rent, thousands of servers for 2 months and turn them off after Christmas, right? So this elasticity makes it a very usable scenario for certain scenarios. It can even provide virtual desktops, just like we have right here, right? If we bridged it out and had an IP address, you could remote to it, from anywhere and act like it's just desktop, right? I mean, you can do these virtual desktops, and you can do developer loads, right? So one of the beauty of cloud computing is, right, you can set up developer loads and things like that, and testing very easily and quickly, just like virtualization, because they're using virtualization to do cloud computing. So, and this is just an example here. You got a laptop, smartphone, or tablet connecting to a virtual server, getting some kind of application or use out of the cloud. So traditionally, right, all the hardware, software, and everything was located and managed in our shop, right? We had it in our organization, we owned it. That was the traditional model. Now, with cloud computing, we can do infrastructure as a service, where they provide the hardware and maybe an OS, but we're responsible for managing the servers and things like that. Platform as a server is they will definitely provide the OS, but they'll also manage the OS on top of it. And then software as a service is they provide everything, but they just really just give you the application. And this is just a graphic view of it. So the real difference between IaaS, infrastructure as a service, and platform as a service is an IaaS or infrastructure, the OS, you're responsible for some of the OS, right? Whereas a platform as a service, they're responsible for the whole OS. And then it comes with, they got this term, anything as a service or X as a service. So they're giving some examples. So like email, social media, online games, customer relation management, they're examples of software as a service. Platforms as a service is, web servers. So if you go and rent a web server from somebody, that's technically a platform as a server because they've installed the OS and everything. They've racked the server, and they've even installed a web server probably on there. And so then you're just responsible for putting it on the web pages, right? And then infrastructure as a service, right? They give examples of cloud storage or web hosting, but it could also be, bare metal servers with Windows or Linux installed, and then you install your apps on it. And then if you flip the triangle, you'll see the amount of users, right? So software as a service has many end users, right? Just about anybody and everybody in the world is a software as a service user. If you use Gmail or any kind of thing like that, you're basically using software as a service. Platform as a service, right? Application developers, not as many people are going to use platform as a service, and then even fewer will use the infrastructure as a service. Mainly your larger companies, mostly, yeah. And then we have different various levels of cloud service, right? So you have the types, but then we have models. Public cloud, right? So like Gmail, things like that, they're accessible to the public, right? They're provided over public transmission lines. Private cloud is kind of like the traditional model. We own all the equipment, but we set it up in a way that it's elasticity. We have our own private cloud in-house. And I got to help develop and design a private cloud at State Farm, and I actually, I kind of automated it. That was the fun part. So we made it so that our developers and projects could request their own servers and their own workstations, and our cloud would design, just build them instantly, and fairly instantly anyway, on our own private cloud. We had it in our own network, and nobody owned it. It was private. But then we could have community clouds where a couple of organizations get together and buy the materials to have a cloud, and then they share it between them. That's very rare. I mean, I don't know of too many companies that get along that this would work too well, but it's available. And then hybrid cloud, which is probably almost anybody that has a private cloud probably has a hybrid cloud, just for the simple fact that there's certain things the public cloud does very well and cheaply that it's not worth their time. But the reason for a hybrid cloud is mostly organizations want to hold their data, right? They don't want to give their data out into the public cloud, right? There's a lot of issues surrounding data, right? There isn't a day, I think, goes by that there's not somebody's been hacked and data lost, right? Right. But your data, these contracts with the cloud companies, you got to be very careful what it says. What happens when you cancel a contract? What happens to your data? Do they delete it? Do they sell it, right? Do they own it, right? Because some contracts, they own the data, right? Even though they don't, right? But you got to be careful what you sign up for. And then the other thing is what happens if their service goes down, right? In a lot of cases, say in this example, you have 4 or 5 web servers that you're hosting on Amazon. Amazon's hosting 5 web servers for you, and your company's making $1 million a month off of sales. But all of a sudden, they go down, and you're down for a week. It takes them a week to figure out what's going on. You pay Amazon $400 a month, $100 a server. They cut you a check for $100 because you were down 1 week. You lost $1 million, but you get a check for $100, man, because that's all the contract accounts for, right? So I mean, you got to be very careful how you design things and what you got to understand what you're. That's if they give you anything back. I mean, they may not even give you anything back because it may just be best efforts. But you got to be very careful. Yeah, it may be a great deal, but when it's not there, and dealing with large companies can be really brutal, very brutal. And then heaven help you if you've got a phone company involved in the mix with a cloud provider. Because I remember in the days I'd have customers, and there would actually be like 2 or 3 phone companies responsible for their telecommunication lines and for their business was down, and I go in and I know what the problem is, but I've got to herd 3 phone companies and then get them to agree that what the problem is, and then get them to straighten it out and fix it. And I mean, literally, I mean, a whole day is shot if you're lucky, because they don't cooperate with each other very well. But the whole business was down. I remember one business in general, they were down the entire day. It was a simple fix. It was such a simple fix. But I had to get the phone companies to make the switch. And the whole business was down for a whole day, and it was a large business. And then that's some of the risks, right? I mean, it's just uptime, data security, all kinds of issues that you just, you expose yourself when you do a cloud environment. It's great, privacy. It's cheap, privacy, right? Whose data, who are you sharing, right? If you're on a cloud server, what other companies or people are on that server with you? Right, because there's a lot of hacks that have happened where they've circumvented the hypervisor and they went from one VM to another VM, right? So who is else on the server that you're on, and then also the technicians at the company, how do you trust them, right? I mean, you have to give them some trust, but they have full access usually to everything of yours, including your data. So you got to trust all the technicians at the provider that you have because they have full access. But the big one that I worry about is who else am I sharing space with, right? Unless you're buying enough space that you own all the space, right? And you're not sharing, but there's no guarantee, right? Unless you have it in the contract. But then you're paying for it. Right, so there's some ways you can reduce risk, right? Do you access it from the internet, or do you get a leased line or dedicated connections, right? So there's some ways to limit your risk, but I mean, you can be liable for all kinds of fines, lawsuits, and possibly even criminal charges. But that's with anything, especially on the web. If you're international, you're global. I mean, it's almost a guarantee you're breaking some law in some country somewhere just for being online. I mean, it's almost that bad. Luckily, most of them don't find you or sue you, but it's very possible, right? And it could just be as simple as you're you're offering ads from Google. Google's sending ads onto your website, and then they show an ad for something that's objectionable in some other country. And boom, now you're liable. Yeah. I mean, the legalities of computing in our global environment has gone really crazy. I don't know how businesses operate in a global environment. I really don't. All right. So I think I'm going to stop here before I get into encryption. Yeah, we'll stop at encryption for tonight. So just make sure, you can just power down the VMs when you're done with them. You can just, you can just close out and just say power off. That's the one thing about VMs, especially in our labs, you don't have to treat them nice. So just make sure that you're working on the video project, the lab wireless radius, right? The Packet Tracer lab. Those are the two big things this week. So, and then we'll cover the rest of virtualization, well, actually cloud computing, on Wednesday. All right.